Hello everyone. Can you guys hear me?
Yes.
Okay. Good. All right. Welcome to the Unity workshop. And so today would be the part one of the workshop. And this is the Discord server if you haven't joined already, but I'm pretty sure you need to join this meeting link. So before we start, I would assume y'all already have downloaded Unity Hub. And so before we start the workshop, I will urge you to have Unity Hub as well as install one version of Unity 2022. So in order to install that, you can go to installs, click on install editor, and download any version that starts with 2022.3. And this would be fine. So the download is about 6 gigabytes. Show you here. But if you haven't downloaded already, please download it, and you can choose to use Visual Studio Community as your IDE, preferred code editor, as well as use this WebGL support that you can find here. So please make sure that you have both of these ticked, and as you can see, it takes 8 gigabytes. Okay, it's a bit more than, but yes. So we'll be having a live coding live tutorial session to get this through. So it would be preferable if you already have the editor installed. Secondly, you want to go over to projects, and once you have the engine version installed, go to projects and click on new project. So this is because the project creation takes somewhere around 5 to 15 minutes, depending on how fast your computer is. And I would usually create it first before I start the workshop. So here, in this interface, you want to select Universal 2D and then give your project any random name. Start. And the location here, you can put it in any folder. So the organization, you don't care, and then you can untick connect to Unity Cloud because we'll be using Git and GitHub in one of the later sessions of the workshop. So once you're done, click on Create Project and let this run in the background, which, as I mentioned, this will take about 10 to 15 minutes. So while this is going on for me as well, I'll be going through the introduction slides. So let me start with the introduction first. Hello everyone, I'm Li Yuan. I'm the president of NUSGBG for academic year 24-25, and I'm also the Unity workshop head for this semester as well. So I'll be guiding you through all the 4 sessions of Unity workshops this semester, which teaches you the basics in Unity programming and how you can use the Unity engine. So why would you need, why would you want to use Unity? Well, first of all, when it comes to game development, you would need some kind of game engine. It could be a commercially available game engine, or it could be any kind of proprietary game engine. But the most important thing is you have the game engine, because what the game engine does is it handles all the complex underlying technologies for your game. For example, your physics system, for example, your rendering pipeline system, such that your game will be able to show up on your device's screen. So these kinds of systems have been implemented on have been implemented in the game engine, where you, as a developer, will not need to touch all of these complex systems, and you'll be able to use the engine as is and create a game with, well, I would say quite minimal effort, depending on how complex your game is. But as you can see, if you follow through this tutorial, making a basic game is not very that difficult. So the use of a game engine facilitates the development process because it already has all of these complex systems implemented for you. So it has a ready-to-use environment. It's a typo here. And it allows you to focus on the design of the game, whether in the game design part or the art design part, but just the design aspect of creating a game instead of thinking about how you want to write your code. And this allows your development process to be much faster, as well as give you the ability to make a more interesting game, because you don't need to spend so much time cracking your brain about what is the correct physics equation to use in this particular scenario. Aside from that, various different types of game engine provides different levels of cross-platform support. As mentioned in the welcome tea, Unity provides support for basically all platforms that can be gamed on. So this includes PC, this includes your mobile, either in Android or iOS. This also includes all kinds of game console, including Xbox, PlayStation, and Nintendo Switch, as well as support for VR, AR headset, and Apple's Vision Pro, and all kinds of different PC operating system as well. We're looking at Windows, Mac OS, and Linux. So it has support for all of these. It has support to build to all of these platforms with very minimal effort, and you don't need to think about how to build to it. It usually is just a one-click button, as I'll be showing you in the later stages of this workshop, where we'll go through how to build the game. So aside from that, the pros of using a commercially available game engine is that you have access to different types of forums, such as Stack Overflow and the Unity forums in this case, which gives you a lot of resources as to commonly asked questions and the common solution to these kinds of questions. And there's also support. There's also like ChatGPT and large language model support. So you can ask ChatGPT if you have any kind of questions regarding writing code and programming in this in your game engine, programming in the Unity engine. It's not really limited to Unity, but Unity has a pretty good support for all of that. So some of the popular commercially available game engine choices include Unity, which is what we'll be teaching in this workshop, Godot, which is what they will be teaching in the other workshop, and Unreal Engine, which is a very high-end, cutting-edge engine for 3D games. So after all of this, you would ask, like, why would you choose Unity over the other commercially available game engine? So as explained, it's free. It's very easy to learn. C# is a very easy language to use. It's well documented. We have scripting APIs. Like references all over the place that you can find on the Unity website, which covers every single API that you would use. There's an active community. We have forums, we have Reddit, we have subreddits for Unity programming support. There's a large number of assets, as I will be showing you in the next session. The Unity Asset Store, which contains a lot of free and paid assets that you can use for commercial games, for commercial purposes. There's multi-platform support, as mentioned. You have support for basically every single mainstream platform that you can play any games, any video games on, as well as it is still the most widely used engine based on market share. So you may have a better chance of getting a job if you know Unity. So the basic timeline of this workshop is that in this particular session, we'll only be going through setting up as well as the basics in writing C# code and C# script for Unity. And to expose you to this, we'll be going through a very simple player control system, which tells you, which probably give you a good idea on how the script looks like and how easy the C# programming language is to pick up. So just to do a very quick poll here, how many of you, just raise your hand with your reaction. How many of you do not have any prior programming experience? Hands, participants, this. Yeah, don't be shy, it's fine. I also joined without any programming experience as well. Three, okay, yes. Okay, good. Four. All right, please put down your hands. Anyone here would believe that they are, a very experienced programmer? You have worked on several projects of your own. You know the ins and outs of programming, as well as any kind of programming principles and software engineering principles. Can we have a show of hands? Okay, I would assume there's none here. So finally, if you are from the School of Computing or you have a minor in any course, any majors from the School of Computing, please raise your hand. I just want to see what is the demographic that we have here. 6, 7, 7, 8. Okay, cool. Okay, please put down your hands. I think I have a pretty good idea. So, okay. So, without further ado, if you have joined and created your project in the Unity Hub, you should be able to already have this interface to you. And in case if you came late and you don't know how to do that, first you would come to Unity Hub, make sure that you already have a version of Unity 2022 installed, because this is a version that I'll be using during the tutorial. And different years and different versions of Unity generally have some differences in their API support. Not major, but I won't be able to help you too much with the version mismatches. Then finally, you would want to, after you have the engine installed, click on New Project, select Universal 2D, we'll be making a 2D platformer. Give it a name, select the place where you want the folder to be in, and then untick Connect to Unity Cloud, as we'll be using Git for this workshop at the end of this series of workshops. Okay, so once you're done with that, just click on Create Project, and it takes about 5 to 15 minutes, depending on your device's capabilities to this editor. So I won't be waiting for the latecomers, and I'll be going to directly with how the UI actually looks like. So in this editor UI, there is a ribbon menu which contains a lot of different things, but we don't generally use the ribbon menu as you need to bring up some new window that is not already On this left side here, we have a hierarchy. So this is the hierarchy of all the game objects that you have in your scene. A game object is the smallest unit of object in the Unity game engine. Basically, what you can think of, everything that you can think of is a game object. I could create a 2D object here. For example, I create a circle. This is a game object. The camera itself is a game object. And anything that you can think of that you want to put in your game scene is a game object. But what is a game scene? So think of your scene something similar to a level. This entire setup here, this entire screen in the middle here, is the editor for your level. Is your editor for your level. And basically everything that you put in this scene here would have a chance of being seen by the player because the camera is here. So the camera denotes what is the section in which the player can see in your scene. So for example, if I have a circle here, you can see that in this camera, I'll be able to see the circle from this camera view here. From this camera view here, I see this in this particular position. So if I move the circle around, I move the circle out of it, you'll see that the circle no longer shows up in the camera view again, because this circle is not in this bound in which the camera is viewing. So this camera bound, or this white line that you see here, denotes the area in which your camera will be able to view and what the player will be able to see in their game screen. So this is the hierarchy view. This is the scene view, and right next to the scene view, you can see a game view. So the game view is essentially what the player would see, and this is where you'll be previewing your game. We have the project view here, which shows you several different folders. And the assets folder specifically is where you will be putting all of your game assets. This includes your art materials, your audio materials, and any kind of scripts that you have, any kind of C# programming scripts that you have. So these would all be inside of the assets folder. This folder generally will not be shipped to the player, but when you build the game, it will do something to it and try to obfuscate it. But this is not very important for you. We have the console tab here, which basically tells you any kind of errors, any kind of message that your editor gives you. And you will be able to program your scripts such that it outputs to the console to help you in debugging. Think of it probably, it's just the console, it's your program's output. We have the inspector here, which when you select any game object from the hierarchy, the list of properties that this particular game object contains will show up here. In Unity, every single one of these are actually a specific type of script. It's just that it's built in. So we call these components. So every game object would have its components. And it will at least have a transform component, which denotes where the object is in the world, in the scene. So if I move this camera around, you'll see that the values of the position change. So this is the transform values. And the other components is reliant on what kind of object that you put, or what kind of behavior you want your object to have. So it depends on what kind of behavior you want your object to have. If you want it to have more behaviors, then you would add more components to this object, and the behaviors sort of just composite onto each other. So we'll talk more about this when we start programming. For now, just know that this is the inspector view. And in the Unity, in this particular editing UI, you'll be able to do a lot of different customizations. For example, you can just move things around. Like you don't want the inspector to be here, you want it to be here, you can do that. You want to dog it back, you can do that as well. You want this to be a floating window, you can do this as well. So there's a lot of customization options that you can do with it. And you should try to customize this to a layout that you like. Personally, I like to have my game view and my scene view to be side by side. So what I do is I just drag the game view and then I drag it to the right side of this window. And now I have my game view and my scene view side by side. So this allows me to always have an idea and a preview of what the game looks like to the player. So this is the editor layout done. Now, in this case, I think we can get started with actually designing a level or using this editor to make your own game. So far, are there any kind of questions? If you have any questions, just type it in the Zoom chat. I'll check it from time to time. And if there's no question, I will keep moving on. It's recorded, so if you don't understand something, you can watch the recording. And if you still don't understand, you can check in with me in next week's sessions. Okay, we don't have any questions so far. Let's get started with this. So we're going to be making a 2D platformer game. And in the 2D platformer game, there are several kinds of aspects. Can I have a say in the chat? So just type in what you think is important for a platformer game in the Zoom chat. So what are some important aspects when it comes to a level in a platformer game? Or you probably have played like Super Mario, something similar before. Ground level, okay, yes. So we need to have a ground or somewhere the player can stand on. Yes, that's pretty good. That's very important. A character, yes, you need something that the player would be able to control, so that they know where they are. Okay, good. Anything else? Obstacles, yes, to increase the difficulty of what the player would face. Correct. That is also very important in designing a platformer. Mission objective, yes. So some way that you can probably motivate the player to clearing the level, maybe a finish line somewhere. Yeah. Movement, background and movement. Yes. So we will also probably need a background. We need some kind of way for the player to move around in the level. Yeah. So these are all correct. So you guys got it. Okay. All right. So let's start with the most basic one, okay, which is mentioned at the very start. We need a ground. We need somewhere that the player could stand on. So for simplicity, for simplicity, I'll just be using like a rectangle, a long rectangle to represent the ground. So we're gonna start off with creating this rectangle in the scene, because right now the scene is empty. We don't have anything here. So what you can do is you just right click anywhere in the hierarchy view or in the scene view. You just right click and scroll down to 2D objects. And you'll be able to see sprites. So sprites is the term in game development we use to call for things such as just art materials, just 2D arts. We call them sprites. So in sprites, you just click on square, and now the square shows up on the screen, and you can see that in my game view that the sprite that the square is also here. So once you have created a square, you'll notice that there is a star right next to the sample scene here. This star indicates that there are unsafe changes. Unity does not auto-save a particular scene for you. So make sure that after every change, if it is important, you save it with the hotkey Control S, just like how you would save a Word document, to ensure that your progress is not lost in case the editor crash. The editor will crash, just like every other program. So make sure that you have the habit of saving properly. So after you have saved, you see that the star goes blue, which means that the changes have been saved. So inside of this square, inside of the scene, we want to move the square around. And there are several different tools here that you have. There's the view tool that moves the camera around. Not the camera that you see here, but the camera in the scene view around. You have the move tool, which when you select any game object, it brings up the gizmos, or the X and Y axis, however you want to call it. It's called the gizmos. So it brings up this gizmos, which allows you to drag it along one axis, or you drag it freely by pressing on the square here. So we probably want to put this like directly in the middle, and you can just put here, and then maybe somewhere here. In this transform component here of the square, just make sure you select the square, and you can see the transform component. You can also type in a numerical value to change the position of this cube. For example, right now we're at 0.01 in X. If I type 1 in X, you see I actually move the center of origin. So let's just center this properly, and we're going to put 0 here. And for Y, we are also going to just leave it at -2.5. So again, save before forget. So other than the move tool, in this ribbon here, we also see there are other tools like rotate tool, which allows you to rotate this object around any of the 3 axes that you choose it to be. Yes. And you might be wondering, hey, it is a 2D space, why can you rotate on 3 axes? And this is because the other technical details is that in Unity, the 2D engine is just a squashed version of the 3D engine. Yeah. So the 3 axis of rotation still exists. That is hardly important. So we can move on. And so the scale tool, which brings up this this gizmo, that allows you to scale this object on a particular axis. And you can also scale on both axes by clicking on the square where both of these intersect. You might have noticed that the scale thing in the transform component also moves. And yes, you'll be able to edit this and still change how it looks. It's directly from the transform. So if you need very accurate position of a very accurate position for numbers, you should just use the transform component here instead of eyeballing where. So aside from typing, you will also be able to just hover over any of these X, Y, Z letters, and then as long as you click and hold and you slide left to right, also be able to change the scale based on like a slider. So you can press Ctrl Z to undo and Ctrl Y to redo. applications as well. So aside from that, there's also the rect tool that allows you to change just the vertices of a particular object. And what it's going to do is it's going to translate the transformation that you did with all the vertices to the specific transform positions, the transform values in the component. As you can see, if I drag this around, both the position and scale is actually changing. Okay. So yes, there's also the transform tool that brings up basically every single one of this except the rect tool. And you'll be able to work on this all at once. So yes, now that we have that established, I'm just going to make this platform extremely long so that this covers most of the capital. So we have the ground as the platform here. The second thing we will need is a character, right? So for simplicity's sake, I'm just going to use a different shape, which in this case, I'm just going to use a circle to represent the player. So I'm just gonna right click to the object sprites and select circle to create this player object. So now we have a square and a circle. It probably doesn't sound like, if you have to collaborate with other people, you just come back to this project after a week, you would have forgotten what is a square and what is a circle. You probably want to give them some custom names. And in Unity, you could easily do that by either right-clicking and select rename and type in any name you want. In this case, the square would be the ground. Or you can use the hotkey F2, which is available just as rename in most other applications would be, and then just change its name. So in this case, I'm going to change it to player. So we have the player as the ball here. If you double click on a particular game object in the hierarchy, the scene view will automatically zoom towards that object to quickly show you where it is. And it also highlights it in the scene view. So as you can see here, when I select player, the circle is highlighted. When I select ground, the platform is highlighted, and vice versa. So now we have a ground and a player. And if I click play here, this allows me to preview the game. Let's see what happens. Okay, nothing happens. Probably think that, oh, it magically would know that, the ball should have physics, the ground should be something the circle would be able to stand on, and you can control the player around with your keyboard, but no, it doesn't work that way. You need to program it as such, and this is what this workshop is for. So, introducing the first component that you'll be learning in this workshop, and it is called a rigid body, and the 2D version is the rigid body 2D. So what is a rigid body 2D component? Basically, it is a component that tells Unity that this game object needs to simulate physics. And once you attach this component onto any game object, the Unity engine's own physics engine would apply to this object and start calculating different things. For example, it will calculate gravity, right? It will calculate force, outer force, it will calculate friction, it will calculate linear drag, angular drag, all these kinds of different properties that you would expect in a real life physics, It would do all of this simulation for you in its underlying implementation, and you do not need to know how it is being implemented in the background. You just know the way it works. So every rigid body object has a mass, has gravity, has drag, which either is linear or angular, as well as velocity, which either is linear or angular. So if you have taken physics in your high school before, you would probably already know about these terms. Anyone here have not taken physics before? Okay, I suppose no. Let's assume that. Okay, so in order to attach this component, you first need to select the game object where you want this component to be attached to. In this case, we want both the ground that the player may be to simulate physics. You would assume like, oh, the ground needs to give force to the player, so the ground probably needs to also be simulating physics. So let's do that. So here on the ground object, I'm going to select it and scroll all the way down. And you will see this Add Component button. You click on it, and it shows you all of these different types of components the first time you use it. And you would be like, oh, that's a lot of things. And this is where the search bar comes in handy. So as we already know that we want to use a rigid body object, a rigid body component, all we do is type in rigid body in the search bar, and you can see rigid body and rigid body 2D. We want to use the 2D version here as we're making a 2D game. So just click on it, and this component would automatically show up in the inspector. You see rigid body 2D here. Okay. And there are different types of properties here. Let's not care about it first. Let's just attach both of these components, both of these rigid body components to both the ground object and the player object. Once you're done, make sure you save, and let's click on play. So you would probably expect that the ball now falls onto the platform and stops on top of it. Let's see if this works. Okay, so they're both falling in the scene together. And this is because both of these objects, they simulate gravity, as mentioned in the slides here. A rigid body will be affected by gravity. But obviously, we don't want the ground to be affected by gravity because it's the ground. It's not supposed to be affected by gravity and fall in the game scene. So what we're going to do is to use one of these types. So in the rigid body type here, in the rigid body component, you see there is a field called body type, which has three options. It's dynamic, kinematic, and static. So dynamic rigid body objects simulate all physics. This includes gravity, drag, as well as external forces that is applied to it by other rigid body objects in the scene. We don't want this to happen, specifically because the ground should not be affected by gravity. So what we're going to do is to change the body type to either kinematic and static. The differences is that even though they're both not affected by gravity and force, a kinematic object will still be movable through any kind of behavioral and C# scripts that you attach to it. But they're both essentially just non-movable. So you will want to go to ground and select the body type and change it to static here. So now that the ground is immovable and is no longer affected by gravity, you expect that the ball would fall onto the platform now, and the platform does not fall down. Let's see if this works. And no, it doesn't work. Well, sort of it works because the ground is no longer falling down, but the ball does not stop on the ground. It does not stop on the platform. So, what are we missing? It's not being. We would usually call this like it's not being. Uh, there is like no hitbox, and this is what we need to do. I forgot to add the collider thing here. So basically, in order for the engine to know that objects can collide into each other, we need to specifically tell the engine that objects can collide into each other. And in this case, the ball, the player, needs to collide into the platform and stop. So what you need to do is you go to ground, and then you need to add a collider component. And since the ground itself is just a cube, it's just a big square, we're gonna use the box collider 2D component, which automatically would have the collider be on the same size as the square itself. And we also need to let the engine know that the ball will also be able to collide into other objects. And in this case, we need to go to the player and add the circle collider to the component. So once both the ground and the player object has a collider attached to it, you essentially let the engine know that these two objects will be able to collide into each other. So let's click on play. Now the ball will, well, it just falls and stays on top of the platform. Okay, cool. So now that this works, you would think that it's about time for us to add some kind of movement such that the player will be able to control the inputs. But now, as hard as I press my keyboard, it does not move. This is where writing C# scripts comes in. And before I move into that, is anyone confused about any of what I have explained just now? Just leave a question message in the Zoom chat room anytime that you're confused, and I'll be able to attend to it as soon as possible. Can you use collider only for ground? So what you mean is if I remove the collider on the player object. Let's try that out. If I remove the collider on the player object and I press play, it still phases through. To the Unity engine, something can only collide into some other thing if both objects, as in no rigid body for the ground. Yes, you will be able to do that. So if you do that, essentially you just tell the engine that you don't want to simulate physics for the ground. And it's essentially the same as having a static rigid body. Is that clear? So yes, you don't really need the rigid body component on the ground because it doesn't need to simulate physics to any extent. That's the short answer. Okay. Any other questions before I move on? See any questions being typed. So I would assume that everyone is okay. But that's a very good question by Daryl there. Yeah, usually you don't put rigid body on the ground object because having extra components increases the CPU. That is unimportant as we start the workshop. Okay, so let's move on. So now we need to start writing programs and start writing code such that the player would be able to, the player object would be able to receive input from the player sitting in front of the computer to move around or to do any kind of action within the game itself. So the way how we do it is first, before we start writing code, you need to configure your Unity environment. So you want to go to Edit, the Edit ribbon, scroll all the way down to Preferences. In this Preferences window, you want to find External Tools. This allows you to define what preferred script editor that you want to use. And because of the nature of C# and .NET, if you don't configure it correctly, you don't get IntelliSense, or what we call code autocomplete. If you're familiar with Visual Studio Code or Visual Studio, you should know what code autocomplete is. And I will show you later why it is very convenient. So in external tools here, you want to click on external script editor, scroll it down, and select either Visual Studio or Visual Studio Code. I prefer using Visual Studio for C# development because the IntelliSense is better and it feels much more sophisticated with a lot more tools available on my disposal. But if you only have Visual Studio Code installed and you don't want to install another code editor, feel free to use Visual Studio Code. It's not that much different since based on what we're going to be doing in this workshop. So after you select it, it will automatically change. But make sure you click on this, Regenerate Project Files. If you don't do this, you don't get IntelliSense as well. And this takes just a very short while because this is still an empty project, sort of an empty project. So once you've done that, you have correctly configured your code editor and you'll be able to move on writing code in much higher efficiency. So we want to structure our project properly such that it is possible to find all of our assets very quickly. Imagine you have a very, very messy folder on your desktop. You will be able to find where you put one file very quickly without using the search function. Sometimes we probably don't know what you save the file as. So it is a good idea to always have a good folder structure set up. And in this case, you can right-click any of this in this asset view, in this project view, and then select Create, and you can create a folder. So I'm going to name this folder Scripts, which contains all of the scripts that I will be using in this project. And you'll be able to double-click on it to open the Scripts folder. And now we want to start adding scripts to it. So again, you right-click Create, you should see a C# script template here. And here, I want you to add, you can change your name here, which I highly recommend changing it off the bat, because if you don't change it now, it's much more difficult to change it later and make sure that your project is still working. So I'm just going to name this player movement, and then as you click Enter, this name will be saved. And then it will reload your editor with this new script. But this script still does nothing because we have not programmed the script. We have not added any code into the script. So now you will double click on this script, and this should open up the code editor that you have configured just now. In my case, it is Visual Studio. In your case, it might be Visual Studio Code, or it might be something else. I don't know, maybe someone uses Notepad++. Anyone uses Notepad++. I hope you're not using Notepad++. Okay. Right. So in this, so it just looks like a basic code editor, right? I mean, it's not that much different. But every Unity script that you create through the Unity editor will usually have this template already set up for you. So it tells you the class name. In this case, we have player movement as the class name. And then it inherits from another class called mono behavior. So mono behavior is the base class for Unity game objects. And if you need to attach this this behavior, like this script, onto any game object as an additional behavior, you need this script to have mono behavior attached to it, such that it could interact with other things in the game scene. Just make sure that you have mono behavior. It's not a must, but for the most case, you would want this to be here. So there's also a start method and an update method already defined. And from this comment, you can see that start is called before the first frame update, and update is called once per frame. But what is the difference? So in game development, we will probably want things to be things you would probably want your object to have constant updates. For example, right, if you play any games, as you move around on your keyboard, you would notice that the moment you press any keys, like you press W, your game character immediately moves forward. And the moment you release it, it immediately stops. So this kind of responsive programming is done in most game engines by what we call an update loop. You might be familiar with the concept of FPS, or frames per second, if you play enough competitive games. And they keep telling you, oh, my CSGO runs at 800 FPS, you know, PC, something like that. So this FPS is the smallest unit of time in game development, where you will be able to receive updates. And based on that, you will also be able to receive inputs or any kind of interaction from the player sitting in front of the screen. So 60 FPS is usually the baseline for most Unity games. And every single frame, like 60 FPS, would mean that for every 16.67 milliseconds, this method called update will be called once by the game engine. And this is what we call update. It's called once per frame. Since there are 60 frames per second, this method will be called once every 16.67 milliseconds. It's roughly that number, which is very, very fast, right? And there's also start, which it says is called before the first frame update. So this will be called when the game is initialized, when the game starts, when this object appears in the game scene. The start method will be invoked. So if you're already familiar with programming, you know this is what we call object-oriented programming, where we have a class and we have methods in it. So a class is basically the behavior that we want to give a particular object. This is the template of what in which the object will follow. So you're defining all of its behavior inside of it, and the method is what you use to modify or tell the object to do something. So this is a class. Yeah. So what we want to do here is we want this script to be able to accept user input, and then we want to translate this user input into, well, into the player object in the scene moving around. So how can we do that? First of all, we probably need to define a field in object-oriented programming. So you define this outside of any method, and you want to define this. So let's just start with like public int speed. So the public here stands for the access modifier of your field or your method. Basically, if you have a public method or a public field, this can be accessed by all other different classes in your project. If you put it private, it can only be accessed by this specific class. If you're from CS, this will be mentioned more in detail in 2030S or 2030 if you're from other school for computing courses. But for now, let's just put this public because, well, it's the easiest for us to work with. It's available to everyone. So now that I put this public, right, what can we do with it? Okay. So as I mentioned, if I want to attach a new behavior to a particular object in the editor, I need the component to be attached to it. In Unity, every script that you write that inherits from mono behavior is a component. So you will be able to just drag and drop it to the player object, or you click add component and type in player movement, and this shows up here. So I'm just going to attach this to the player object, and as you can see, this field named speed that we defined in our code editor shows up here. So in this editor, in the Unity editor, we will be able to change the value of speed. And we're defining it as an integer. So it will be whole numbers, either negative whole numbers or positive whole numbers. So let's give this a number. Like, for example, we give this like 5 or 4. Let's give this 4. But this still doesn't do anything because we don't have anything that uses speed in our script. So what we want to do as well is we want to probably work with the rigid body component that we have just added. Remember, the rigid body component contains velocity, which essentially is just speed. So in order to do that, we need the script itself to have a reference, we call a reference, to the rigid body component that is attached to this game object. Having this reference allows us to call methods from it or access properties from it that allows us to change the state of this rigid body component. So here, I'm going to define a public rigid body 2D field, and I'm just going to call it RB, semicolon. So as the level starts or as the player loads into the scene, I grab the reference of this rigid body object, and I can do so with this get component function and put in rigid body 2D here. This is generics. I wouldn't mind too much about it until 2030. But yes, just make sure that you do it this way. So basically, this tells Unity that you want to obtain the component that is attached to this that is attached to the game object in which this script is attached to, which is of type rigid body 2D. It's the same type as what we need. So now that we have assigned this reference to this RB field, we will be able to use it anywhere else in the class. So let's say we do RB the velocity equals new vector 2, which basically is a 2D vector that has an x and y component in this vector. And x is the horizontal axis, and y is the vertical axis. What this line means is I'm going to assign the velocity field of the rigid body component to a vector 2. And the vector 2 basically is the magnitude of velocity in the x and the y component. So here, if I put speed 0, what you will notice that this should make the ball float towards the right. Every frame, the velocity will be reassigned to speed 0. And if you click preview here, you see this is exactly what happened. Okay. So if I put 0 speed on the other hand, this will make the ball move in the upwards direction, as this is the y component here. As you can see here, float y. So this moves up. Yeah. So if I put speed, it should move in the diagonal direction here. And if I put negative, it just moves in the opposite direction. Okay. So now we have a way of changing the velocity, right? And at this point, you might think that having a speed of just a whole number is not very convenient, because what if 4 is too slow but 5 is too fast for your liking? So usually what we do is we're going to use float instead. So float is a type of primitive type available in most programming language and is preferred in game development because it will be able to help us represent decimal numbers with good enough rounding accuracy, and is used extensively in graphics renderings and game development, but that is not very important. So what we can do is change speed to float, and now you will realize that as I move back in, I will be able to give this any decimal numbers. So this gives you more control over how fast you want to hold. And you can fine-tune this value to a value that you like, to a value that you think the player should move, how fast the player should move. So after this, we still need to get the player input. We still need to get whatever the player is pressing on the keyboard. And we still haven't done that yet. So in order to do that, we will be using what Unity provides to us, which is what we call input, the input class. And it contains a method called getAxis. So what this getAxis does is it will be able to get either the vertical or the horizontal axis as input. And usually this would either be the joystick or the controller or WASD on your keyboard. So here I'm going to do input.getAxis. And since we want the player to be able to move left and right first, we will get the horizontal axis. Still, this does not give us a lot of this does not give us a lot of like, what can we do with this, right? So we can assign this to a value, and let's just call this horizontal. We assign this to a variable called horizontal move. So what this allows us to do is to use this horizontal move in the subsequent parts of this method. So the math is that if we detect an input, this input would either be 1 or -1 or 0. -1 basically means that we are pressing the A button on the keyboard, which means we're moving in the negative direction in the X direction. Positive means that we're pressing D. It means we're going towards the right side of the screen, which is the positive component of the X direction. And 0 means that we are not pressing anything. A and D are not being pressed. So once we have established this, what we can do is to do speed times horizontal move. This means that if we either press A or D, our X component would be set to negative speed or speed, which makes it move to the left of the screen if it's negative, or to the right of the screen if it's positive. And we don't want to change the Y position of our player. And if our movement, if we're not pressing anything on the keyboard, horizontal move is 0. So we would just set the velocity to 0, 0, which basically just means no move. So let's try out the hypothesis here. We're going to press play. And oh, as you can see, it just does not, well, it falls down very slowly because every frame we're setting the Y velocity to 0. This means that the gravity calculation will not be able to perform properly. So we need to fix that. We're going to fix this later, but let's just make sure that our input movement is working properly. So now as I press A and D, you can see that I am moving. Well, I press D now, it's going to the right. I press A now, it's going to the left. So this is working as we want it to. But again, as I mentioned, because every frame it is setting our Y component in the velocity to be 0. This means if we do any kind of gravity calculation, it's going to be very slow. Because every frame, this is going to be reset to 0. So it doesn't move properly. So let's do a quick pop quiz here. How do we resolve this problem? Any takers? Any guesses? Just type in the chat if you think you have an idea of what we should do to resolve this issue. anyone. Still typing, maybe. Make vertical move. No. If I have a vertical move, then what do I assign this to? It will still be the same because I won't be pressing W and S, or like the vertical axis input all the time. But okay, that's a good try. Do we have any other guesses? Increase gravity scale. Well, that solves the problem a bit, but that also means that we are still not getting an accurate like simulation of the physics. We want gravity to at least be as accurate as possible. If I just increase it there, then I'm just hoping. Use time.delta time. No, that still doesn't work properly. Yeah, there's a better way to do this. So I'm just gonna give you the answer. Is that let's just not assign a new value to the y component. And we're just gonna reuse the previous value. And how we can do this, we just do this. So what this does is every frame, we're going to assign a new velocity vector 2 value to the velocity component, where the x is equal to speed times horizontal move, which is the speed times whether or not the player has done any kind of movement. And we are going to put rb.velocity.y, which basically means the y component is going to be the same as what it was when this frame is being invoked. So as we do this, we can ensure that every frame, our y component is still being calculated properly. And as you can see here, this is exactly what it does. So we don't want to modify it, then we just reuse the same value. Yeah, that's the general gist of ideas. Okay, so now that we have both of these, what else do we need? Okay, our player can move left, right. Do we need anything more to the player movement? Jump. Yes, we need the player to be able to jump. So how do we make it jump? Thank you, Copilot, but I don't need you to give me suggestions. So in order to get the jump input, we first need to know if the player is pressing down on the jump button, which in most cases you would probably put it to your spacebar. That's like the international input at this point. So what you're going to do is first you check if this space bar key is being pressed down. By checking if the key is pressed down. As you can see in the get key down method, the tooltip says returns true during the frame. The user starts pressing down the key identified by the key code enum parameter. So as the key down is being pressed, we will be able to jump. Or at least we want this to jump. So in order to test whether or not this is working, we can use something we call debug.log. And this tool, this debug.log tool, the method itself takes in a string, and it allows us to print this string to the console tab that we have in the editor. So ideally what we're going to see here is as we press down the space button, we will see this string jump being outputted on the console, in the console. So let's try this. See here, the jump is being outputted. Hey, that's good. So now let us implement the jumping thing, the jumping logic. So you'll probably also want to define a jump speed. And this allows us to get how fast we want, like how fast we want the initial velocity of the jump to be. And similar to what we do here, we're just gonna do our meter velocity equals new vector 2. Keep the x component, so if the player is moving left or right, they will not be interrupted. And then just change the y component to jump speed. So we were going to have this jump directly upwards, and since this only updates one time, when the key is being pressed down, we will just have this done once. So let's try this out. And as I press space here, yes, I forgot to say. Oh, okay. I forgot to assign a value to jump speed. So make sure you do that. So let's give jump speed like 3.5. So now as I press spacebar, you can see that it now jumps properly. Okay, it's cool and all, but at this point, you probably would have noticed that we don't care where the player is when they press the spacebar. So if I spam it, they can jump infinitely. So how can we solve this problem? Obviously, we don't want the player to be able to jump infinitely many times when they are in playing a platformer game. That's basically just cheating. Do we have anyone in the chat that could tell me what we could do to avoid this issue? Yes, okay, I see 2 answers. Correct. So you check whether the player is on the ground. Okay, so yeah, you check the player is on the ground. And Joshua gave us a very good direction to look into. Raycast. So what is raycast? Basically, raycast is, in game development terms, a technique where we draw a line between 2 points and see if any objects exist in between these 2 points. This is what we call raycast or raycasting. So what we can do to check if we are on the ground or not is, okay, maybe we want to have a method that returns a Boolean. Boolean is basically a true or false value, and we're going to call this is grounded. So what we want to do in this is grounded method is to check if the player is on the ground. And one way we can do this is to use the raycast class as explained. It draws a line between 2 points to determine if there is anything in between these 2 points. So where do we want to draw the line between? We want to draw from the center of the player down to somewhere over, a little bit over the side of the player here. Okay. So you'll probably draw from the center all the way down, vertically down until somewhere here. So if we do that, we will be able to know if the player is on the ground by checking if there is an intersection of an object that is not the player that we can sense here, that we can see here from the raycast. So what we're going to do is we're going to call physics 2D.raycast. So we're going to call it from the middle of this circle, which would be transformer. We want to call this all the way down in the vertically down direction, which would be down. And what is the distance then? The distance would be slightly larger than the radius of the circle. In this case, this would be 0.5. The radius of the circle is 0.5. So that is like the default size of the circle since we have not changed the scale. But this changes. So I'm just going to do 0.5. And we give this a little extra. So if the feet is just slightly on top of the ground, we will still be able to jump, ideally. So this returns a raycast hit 2D, but we will be able to just return it as is because in C#, as long as this returns something, the Boolean value would be true. If there is no raycast hit, if there's no object in between these two lines that we're drawing, this will not return something. So now, ideally what you do is you check if we have received a spacebar input from the player and that the player is currently grounded, we jump. Let's see if this works. Currently, it still doesn't work. So the reason is this raycast method here is going to return all objects that it sees, that it collides with when it draws this line. And in this case, it would be from here to here, right? But as you can already imagine, this line is intersecting with this circle. It's intersecting with the player, which therefore returns a result from the raycast and will then return true for this Boolean. So what we want to do now is to use what we call a layer mask. It's a value that is available in the Unity engine itself, which allows us to separate one type of object from another type of object. And this is generally used in physics interaction, where you would be able to label certain objects as certain layers of physics objects, and then separate the interactions of these specific layers of physics objects with other physics objects. So what we do here is we only want this raycast to detect whether or not we are on the ground. So we can apply a layer to the ground object such that the ground itself is on its own layer, and we just need to check in the raycast if we are colliding with any objects that is from this layer. So on ground, I'm going to click on default. I'm going to click on add layer. And this brings up this inspector. And you can see you'll be able to define up to 31 layers, but 5 of these have been used. So I'm just gonna define my new layer, which is user layer 6 with ground. And we save it, then we need to go back to the ground object and change the layer from default to ground. And we change the layer from default to ground. And now, in the player script, we want to refer to this layer mask. So we have the ground layer that we can refer to. And now in this raycast, we just need to check if we're on the ground layer. Make sure you use the dot value here because or else it doesn't actually do it. So what it does is it checks. In this raycast, we specifically only check if there is an object which is of the layer mask ground that exists in between the line that we're drawing here. So we just need to go back to our player object and then to our player script. We can change the ground layer to something else, ground. And now as we save, we can only jump when we are on the ground. And as you can see, I can move around, and this does not change the fact that we can move around and jump. We can only jump on the ground. So yes. Do I have any more slides? No. Okay. So up until this point, do we have any questions? Are we still following okay? Be fast, so I cannot see your reactions. If you have any questions, please type them in the chat. Just wait here for a while. And let me stop sharing because I need to grab something. Yeah, quick moment. Any questions? If you have any questions, just please type them in the chat because I will not be able to see your face and go and ask everyone if you have any questions. Okay, I would assume that no one had any questions. So let me share my screen. So if you have no question, this is the attendance QR code for today. Please scan the QR code so that we will be able to record that you came to this session. And this is required for us to get fundings from School of Computing. So please do me a favor, if you're here today, please scan the QR code. And in the meantime, if you do not understand what I talked about just now, please type it in the chat room. If there are any points that you would like to clarify, please also put them in the chat. So after you scan the QR code, this will be the this will actually be it for today. We learned about how to use the editor and how you can create a very simple play movement script. Meeting recording. I will upload the recording as soon as possible. I still don't know how Zoom is going to record it, but I will do it preferably by tomorrow so that you'll be able to refer back. Your extensions for, yes, it is GameStart week 1. Technically, this is the first week of GameStart. So Daryl asked if the extension for IntelliSense disappeared. You can get it back by going back to here, go to Edit, Preferences, go to External Script Editor, make sure that this is selected properly, then click on Regenerate Project Files, and then restart your code editor. This will bring back your IntelliSense. If you are using VS Code, you should also have the VS Code Unity and C# extension installed. For Visual Studio, you should also have the extensions installed properly. Let me just show you extensions, and then you can search C#. Install C# and C# Dev Kit extension, as well as the Unity extensions here. If you use VS Code, if you use Visual Studio, in your Visual Studio installer, use Visual Studio in your Visual Studio installer, and click on your version, click Modify, and then go to Game Development with Unity and click every single one of these. Optionally, GitHub Copilot. If you do not have this installed, this should show up here and in gaming. Just click on one of these and then click Install. And after it's done, your IntelliSense will be set up. Sorry, we're a bit off course. Do we have any other questions? Will all GameStart workshops be online? We are trying our best to secure a venue as soon as possible. And ideally, we can move back to face-to-face session during the third week of GameStart workshops. But if we aren't able to secure it in time, all GameStart workshops will be online. And yeah, we try our best to secure a venue, but it's not a guarantee. We will update you as soon as possible once we have gotten it. Announcements for GameStart will be posted weekly on Mondays in our social media channels. And even if it's face-to-face, we will still provide recordings, but the recording quality would probably be a lot crappier than the ones we have online. Okay. Any other questions? If not, make sure you have already scanned the QR code. If you are here now, the QR code will expire in about 30 minutes. Yeah. And scanning. And a small weekly challenge for you guys, since this is still the second week of the semester and you're probably itching to start writing some code or programming guide, or you just want to challenge yourself. You can try to do stuff such as advanced movement controls, like wall slide, wall climb, or double jump, just as just just as practice. But if you don't have time for this, it's fine. But it's probably fun, maybe. And to put this into how you might want to approach this, for a double jump, want to maintain a counter as to how many times you've jumped. For wall slide, you'll want to um, use raycast, and it's the same for wall climb. So yeah, you can look in this direction. Okay, and I don't think we need this since everyone should be in the club. So yeah, that would be the end of my slide. If you don't have any questions, we will be able to dismiss now. If you have any questions, you can leave back. I will try to answer them. Thank you for coming, and I'll see you next week. Have a great night. Hope you learned something today. Nothing related to the lesson, but does this mean we are in GDG? If you have verified yourself in the Discord server, then yes, you are in GDG. You should be able to see the GDG logo in your NUS sync as well. If you have the meeting links to this and it's not sent to you by someone else, then yeah, you're in GDG. Yep. Okay, you're welcome. Do we have any questions? Yuchen and Luxiang?